Hello 3D printing friends. Today on the BV3D channel we'll take a look at the brand new Creality Ender-3 S1 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to get our first look at Creality's brand new Ender-3 S1. A big thanks to Pergear for sending this to me for review. Pergear is a company which mostly sells photography lighting and equipment, but also has a few Creality items. So without further ado, is that the same as with further ado? I'll just dive right into talking about the printer. Okay, the Ender-3 S1 is the latest in the Ender-3 line of 3D printers from Creality. It's got roughly the same design as previous models, but adds some refinements. And in the same way that the Ender-3 V2 incorporated several popular upgrades to the Ender-3 and Ender-3 Pro, Creality continues that trend with the S1. So in addition to the Ender-3 V2's features like the color LCD, power supply mounted inside the printer's case, silent stepper motor drivers, belt tensioners, and a handy tool drawer, the Ender-3 S1 adds a filament runout sensor, auto bed leveling sensor, dual Z-axis stepper motors, a removable magnetic spring steel sheet with a PC print surface, and a new lightweight dual gear direct drive extruder that Creality is calling the Sprite. So this makes it the first Ender-3 that ships stock with a direct drive extruder. The hot end sports a standard 0.4mm nozzle, and while it can be heated to 260 degrees Celsius, it's still a PTFE lined hot end, so I don't recommend going over 235 or 240 degrees with it. Its build volume is slightly larger than that of the Ender-3 V2 at 220 by 220 by 270 millimeters, so it can print things 20 millimeters taller than the V2. It also has a new 32-bit mainboard with an SD card slot, yes, the full-size kind that are easier to handle, and a USB-C port. The heated bed's cable and strain relief look a lot beefier too. And Creality hints at some extras you can buy for it, such as a laser tool head and a light bar. Current pricing on Creality's site shows the S1 priced at $399, which is $134 more than the Ender-3 V2. The price difference is actually a tiny smidgen less than if you were to purchase an Ender-3 V2, a filament sensor, a bed probe, a magnetic spring steel print surface, and a dual Z-axis upgrade kit, and a direct drive extruder. Okay, it's only about $1.50 difference, but in addition to saving $1.50 with the S1, you don't have to wire and install all that stuff yourself. So, are you wondering what else comes in the box besides the printer? Well, here's what you get. You get a power cord. You get an SD card and a USB card reader. You get a small screwdriver, a scraper, a set of Allen wrenches, and these are basic, not the usual ball end wrenches Creality usually includes. You get wrenches for adjusting the eccentric nuts on the V-slot wheels and for working on the nozzle, and you get an acupuncture needle that you can stab the nozzle with if it gets clogged. I don't know if that really helps, but it can be a good way to take out your frustrations on the nozzle. You also get a few spare parts. You get a Z-end stop switch in case you don't want to use the bed probe or if the bed probe fails. You also get a spare nozzle. And you get spare screws because there are screws left over on purpose after you finish assembling the printer. Oh, and there's also a warranty card, a couple of Creality stickers, and a getting started manual. But the manual's got finer print than a cell phone contract. US dime for scale. Fortunately, there's a PDF version of the manual on that SD card, so you can look at it on your computer and zoom in on it. Now, I decided against making an assembly video because Creality's already done it. That video too is on the SD card, and you can also find it on Creality's YouTube channel. But I will briefly mention the steps involved. It's actually a lot easier than assembling the Ender-3 V2 because the gantry is already built. So basically, the gantry needs to be bolted to the base. Then the Sprite extruder gets bolted to the X carriage. Mounting the extruder is easy, it just hangs in place and then you secure it with 4 screws. Then put the spindle on the spool holder and snap that onto the top crossbar. Bolt the screen bracket to the side of the printer, snap the screen on, and then plug in all the cables. Finally, set the voltage switch on the back of the printer to match what comes out of your wall outlets and you're done assembling the printer. With the printer assembled, the next thing to do is to run the auto level process. This creates a mesh by probing the bed at 16 points in a 4x4 grid. The mesh is like a topographical map of the bed and lets the printer know where it has any high or low spots. Once the auto leveling process has finished probing the bed, it's time to set the Z offset. And since I've had questions in the past about what the Z offset is, I'll try to explain it better here. See, the CR Touch Bed Probe uses a metal pin to probe the bed. Usually that pin is retracted and is higher than the nozzle. But when the printer homes the Z-axis, it deploys the pin, which moves past the nozzle and closer to the bed. And when the pin touches the bed, the probe is triggered, and then the printer checks a second time, more slowly, and finally the pin is retracted into the probe. So the Z offset value represents how high above the bed the nozzle is when the probe gets triggered. In other words, how much lower down does the Z-axis need to move until the nozzle touches the bed? We'll rely on the paper pincher method to determine when the nozzle is at the right height. So after the leveling operation, home the printer. Click Prepare, then Auto Home. When homing is complete, the printer leaves the nozzle about 10 or 12 millimeters above the bed. Then put a piece of paper between the nozzle and the bed. We're still in Prepare, so click Move, then move Z and set Z to 0. This moves the nozzle to its 0 point, where the printer thinks it should be touching the bed. In reality, the nozzle may not be close enough to the paper yet to pinch it against the bed, but then again, it may be so close you can't even move the paper. But that's why we're here. We're going to make an adjustment. Still in Prepare, click Z Offset and then adjust its value until, while moving the paper back and forth, you feel it being pinched a bit between the nozzle and the bed. The adjustment is live, meaning that as you set the value by turning the knob, the printer is actively moving the Z-axis. The more negative the number, the further down the nozzle goes, and the more positive the number, the higher the nozzle goes. So once you have it adjusted so that you can feel the paper being pinched lightly between the nozzle and the bed, click again to accept that value. Both the mesh data from the auto leveling process and the Z offset value are saved to the printer's memory automatically. Okay, the printer is assembled, the auto leveling is done, and the Z offset is set. What's next? Well, let's load some filament and print one of the models included on the SD card. To load filament, the nozzle has to be heated up, so click into Prepare, then Preheat PLA. This will heat the nozzle up to 200 degrees Celsius and heat the bed to 60 degrees. While things are heating up, put the spool on the spool holder. Then use those flush cutters to cut a 45-degree angle on the end of it. I always make a point of doing that. Get it? A point? Okay. Well, next, feed the filament through the filament sensor. Once the nozzle has reached that 200-degree set point, push the filament loading lever to the side and insert the end of the filament into the top of the extruder. Push the filament on down until it starts swiggling out of the nozzle. Now that the filament is loaded, let's print something from the card. Click into Print to see what's on the card. I think I'll print the rabbit. This little blue bunny came out pretty good. There's just a couple of strings in between the tips of the ears. Not bad for a pre-sliced file. So what's next? Well, you will probably want to print something besides the couple of files that Creality included on the card. That means you'll need to use a slicer, and Creality includes their own custom version of the Ultimaker Cura slicer on the SD card. The software included on the cards can sometimes be dated, so I recommend pointing your web browser at Creality.com, clicking Support at the top right corner, and then Downloads. From there, you can get the latest release of the slicer for Windows or Mac OS. After it's downloaded, install it, and then run it. Follow the prompts, and when you get to the part where you're selecting a printer, pick the Ender-3 S1. From there, it's simply a matter of dragging in a 3D model in STL format, selecting a material type, and then selecting a profile. These are listed by layer height, which affects the quality, and clicking the slice button. I almost always use the 0.2mm layer height for my prints. It's a good balance between quality and speed. If you don't see the material menu, I discovered I have to make the window really wide to make it appear. I think maybe Creality should fix this so it's always visible, even if the window isn't super wide. And I recommend sticking with the generic material types at first. The generic PLA is set to print at 200 degrees Celsius with a 60-degree bed. And it has the retraction set at Creality's suggested 0.8mm at 40mm per second. They're a good starting point. If you need to change any of these values, for instance, if you need to edit the printing temperature or confirm the retraction settings, click the Custom button and look inside the following settings groups: Material for nozzle and bed temperature, and Travel for retraction settings. If you find you're changing these settings all the time, you might want to duplicate the generic PLA and customize it to save yourself some hassle. Anyway, once the model has been sliced, save it to the SD card and eject the card from the computer. Then put the card into the printer, click Print, and select the file to print it. And that's all there is to that. I like that Creality has included settings for pretty much every filament-based printer they've ever made. Okay, next I wanted to test the power loss recovery feature. So I started printing an XYZ cube. I let it run for a few minutes. I think it was on about the third layer. Then I turned off the printer, waited a few seconds, and turned it on again. When the printer powered up again, it asked if I wanted to resume the print, so of course I said yes. And it homed the X and Y axes and reheated the bed and nozzle and went back to the job of printing. And when it finished printing that layer, it promptly jammed the nozzle right down through the print and right through the PC print surface. And just for good measure, it wiggled it around a little bit too. The only thing that stopped it was the spring steel sheet and me turning the power off. I have absolutely no idea why that happened or what the printer was thinking. So now that part of the build plate is just a little bit on the ruined side. Well, that clearly didn't go to plan. Next, I wanted to test the filament runout sensor, so I started a new XYZ cube. Again, I let it run for a few minutes and then cut the filament where it enters the sensor. Once the filament had been pulled past the switch inside the sensor, the printer paused and prompted me to reload the filament, which I did, and then told the printer to continue. And that worked just fine. So, for those of you keeping score at home, it's filament runout sensor 1, power loss recovery 0. I also wanted to check some safety-related things. First, I wanted to check on the high current wiring inside the case. I'm referring to the 24-volt power input and the nozzle heater and bed power outputs on the printer's mainboard. These are almost always connected using clamping terminal blocks, and what I'm looking to see is, first off, if the wires are going into this kind of terminal block, and if they are, whether they're terminated with crimp-on ferrules, or if the ends of the wires are tinned with solder. Tinning the ends of the wires with solder is specifically called out by a manufacturer of this kind of terminal block as a bad practice for high current wiring. And I've got a whole video about that on this card right up here. So I opened the case, and I was quite pleasantly surprised to see that Creality had installed ferrules on the ends of the 24-volt wires from the power supply and on the bed heater wires. They didn't need to do that on the nozzle heater wires because they're using several of the wires in the ribbon cable to carry that current, and the ribbon cable plugs into a different kind of socket. So, ferrules? Check. Next, I wanted to see if Creality had the thermal safety features enabled in firmware. Specifically, I wanted to see if a thermal runaway error could be triggered if the printer wasn't able to keep the nozzle at a given temperature. On 3D printers where I can power the main board from its USB port, I can pretty easily test whether this feature is enabled. But the Ender-3 S1 can't be powered by its USB port, nor does its port provide power out. Trust me, that's for the best. So anyway, back to testing the thermal safety features. My testing method simulates a situation where the temperature sensor becomes separated from the nozzle's heater block. If that were to happen for real on a printer that didn't have thermal safety enabled, the printer wouldn't be able to read the temperature of the nozzle. It would see the temperature dropping and would try desperately to keep the nozzle at printing temperature. And so it would end up leaving the heater cartridge on, getting ever hotter, but it wouldn't know how hot it was really getting. And before too long, it could get hot enough to set something on fire. But with thermal safety enabled, if the printer sees the temperature dropping and it can't get it back up to temperature within a few minutes, it'll show an error and cut power to the heaters. So my method of simulating this event is by bringing the nozzle up to temperature and then unplugging the nozzle's heater cartridge. The net result is that even though the printer is providing power to the connector, the cartridge is unplugged and therefore is not heating. And the temperature drops and the printer can't get the nozzle back up to temp. If the printer has thermal safety enabled, it will show an error and cut power to the heater like I mentioned a minute ago. So I removed the extruder assembly from the X carriage. It's held in place by 4 screws. Then I set it face down on the bed, and in control and then temperature, I set the nozzle to 200 degrees Celsius. Once it was at temperature, I unplugged the heater cartridge and of course the temperature started to drop. And hey, after a few moments, the printer showed an error and let loose with some loud beeps to get my attention, and I had to turn it off to make it be quiet. So, thermal safety? Check. With the safety checks done, let's look at some of the things I printed. The Ender-3 S1 can print a bunch of different filament types. I've printed things in PLA, PETG, and TPU. These were all sliced with Creality Slicer and printed at the standard quality using 0.2 millimeter layer height. Here are some things that I printed in PLA. I printed a couple of retraction/stringing tests. Creality Slicer is using a 0.8 millimeter retraction at 40 millimeters per second, which worked out great. Yeah, there's a wisp or two, but nothing out of the ordinary. And here's a 3D Benchy, which turned out ridiculously smooth. There's one little line here where it looks like a bit of filament had been cooking on the side of the nozzle for a little while and then finally decided to be a part of Team Benchy. I can't really blame that on the printer though, and everything else about this is great. And check out this Calicat. Absolutely perfect. Oh, and these diagonal lines you're seeing are the infill pattern, where it connects to the walls. But the finish seems super smooth. I also printed the iDig 3D Christmas tree in spiral vase mode, or vase mode. I'll just say it both ways so everybody's happy. This is printed at the full build height of 270 millimeters, and it's just awesome. Even the super pointy tip came out super pointy. I also printed a couple of things in TPU. The first one is a vibration dampening foot for a 3D printer. It was designed to be printed with a non-squishy filament like PLA or PETG, but I thought it would be fun to see what happened when I printed it in TPU. Now, printing it in TPU is completely impractical because TPU is far too soft for this design to actually support the weight of a printer. But it came out really, really good and really, really squishy. And totally unsuitable for its intended purpose, but definitely fun to smoosh. Now this, of course, is a tire. I have no idea what it's supposed to fit, but it looked like the kind of thing that you'd print in TPU. Due to being thicker, it's a little stiffer than the printer foot thing, but it's still definitely squishable. And with both of these, there's next to no stringing. I'm super impressed with the S1's ability to print TPU. Now it's time for a PETG print or two. These are printed in Alien 3D's Alien Ooze PETG. Here's an XYZ cube. It came out pretty good. You can see the infill through the sides because of its translucency. But where this filament really impresses me is when it's printed in a single wall spiral vase mode print like this low poly faceted rose vase. It looks like green glass. I think it's a really beautiful result. Okay, so we've gone over the printer, done some safety tests, and taken a look at some prints. Now, I'd like to share what I like and don't like about the printer, starting with the things I don't like. So first on the list, the utter failure of the power loss recovery feature. I have no idea what went wrong with that, but Creality definitely needs to look into it and fix it. I 100% recommend you do not use that feature until Creality declares it fixed, or you're going to have a bad time. Next up, the noise level. It seems quieter than other Ender-3 series machines, but the fan that cools the electronics enclosure and the fan in the power supply are somewhat loud. I also found a couple of temperature-related quirks with the printer. First, in control and then temperature, the nozzle and bed temperatures can be adjusted, but I found that I was unable to set them any lower than 5 degrees Celsius. Even if they're already at 0, as soon as I start to make an adjustment, it immediately jumps to 5 degrees. The only way to set them back to 0 degrees is to go into prepare and then cool down. Second, the auto level feature turns off the bed heater when it starts the probing process. I prefer to have the bed at printing temperature when the auto level feature probes it because the bed's shape may be slightly different between its cold and its heated states, like it might warp just a little bit. Unfortunately, since the auto level feature turns off the bed when it starts, the bed cools off during the probing process, which may affect the readings. I guess the last thing I'm not too fond of is the placement of the part's cooling fan. It blocks my view of the nozzle, but I understand why it is where it is. And now, here's what I like about the S1. It looks pretty slick. It does. I like it. The injection molded front plate pushes the aesthetics of the Ender-3 series forward and looks more consumer friendly. And while the Creality branded edition of the Cura slicer can be a little buggy at times, it is nice, from a consumer point of view, that there's a slicing solution with configurations for every FDM printer Creality ever made. And that makes it easy for new 3D printer users to get up and running quickly, slicing and printing models with profiles tuned for their printer. Also, I find that I really like the full-size SD card slot. The cards are easier to handle and harder to lose. It's also nice that the S1 can print things that are a little bit taller than you can manage with a regular Ender-3 series printer, except for the Macs. The Sprite extruder is quite good. Its direct drive has dual drive gears gripping the filament and has a 3-to-1-ish gear ratio, and it's lighter than other direct drive extruders. And it did a fantastic job with that flexible TPU filament. I also like that the S1 is easier to assemble than previous Ender-3 series printers. And while the other fans on it are loud, the fans on the extruder assembly are quieter than previous Ender-3 machines. And the drawer on the front holds even more stuff than the Ender-3 V2. I can even get that scraper in there. The spring steel magnetic flex plate with the PC print surface is nice. The prints stick well to the plate, and they're easy to remove by removing the plate and flexing it. And I'm pretty impressed with the print quality. Okay, I think we're just about done. I want to mention that this review is based on having spent a week putting the printer through its paces. And while it's not a long-term durability test, my other Ender-3 series printers have all held up really well. I do think the printer could be even quieter. Artillery can do it, so I think Creality can do it too. The Ender-3 series has been getting better and better, so I didn't find much to dislike. Except, of course, I'm really super unhappy about the weird behavior of the power loss recovery feature. So that's the Ender-3 S1. It has a bunch of upgrades over the Ender-3 V2. It's pricier than the V2, but if you were to buy a V2 and upgrade it to the same specs as the S1, it's about the same. The benefit is that those upgrades are already done for you, so you don't have to wire stuff in on your own, and it's easier to put together. So overall, I think the Ender-3 S1 is a pretty good choice if you need its extra bells and whistles. It's probably just a firmware update away from resolving most of the issues I had with it. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BB3D channel.